channel. So in this video we'll just cover the approaches of object oriented database. Actually, like in the last video we have just discussed what is OODB, and in this video we'll just see various approaches. Actually, like when you're speaking about object oriented database, so it always emphasize data organization around the objects, okay, in terms of objects. So rather than storing data in tables such as rows and column format, like in a traditional relation database, it always integrate the object, okay, along with the object oriented programming languages. So where it allows the object to be stored directly in the database, so that we can just get more benefited regarding the object oriented, like whatever the benefit we have, okay, in C++, all these things. So more than that we can just have in this kind of advanced database. So we see various key approaches with examples. Actually, the first approach is object identity. So whenever we have object, so we should have a unique identifier so that we can just get into a distinguish, like in traditional we use primary key, right? So unique ID, which is used to extract the particular attribute in a unique way. So in that case we have object identity, which is nothing but OID. So whenever your object is created, we have to assign an OID as a unique OID to retrieve the particular object or the relationship of the object in future case. Okay, for retrieval purpose we need this. So each object in OODB has a unique identifier, which is nothing but OID, that distinguishes it from other object. Okay, so this OID remains constant until you remove that object from the particular thing. So whenever you have made any changes on the object, okay, the identifier will not change because it is a static one which is have been mapped with the object. To represent object we use OID for that. Okay, so here is an example. So this is a Python code. So here we have an employee, which is nothing but an object. So each employee, they have been like described within function, okay, with a name. Actually each employee is assigned a name here. Okay, so here employee 1, employee 2 or the multiple objects. So each object they have been given an employee. Okay, so employee 1 is like we have thing like for John and Doe, all these things are the names for the employee. Okay, so here employee 1 and employee 2, is there possible to have same values because a name can be repeated? In that case we have to assign the OID, that is object identifier, for employee 1 and employee 2. For example, this can also be a John. Okay, he can also be a John. Okay, there is high possibility of having two names, okay, two same names for two different employees. In that case what I can do, we have to assign an object identifier for an object. Okay, this is an object, this is an object, this is we can have a number of objects. So how to assign an identifier or OID for an object? So this is where we have to be like assign. Okay, so this is your ID of employee 1, so which means that this function or this method just assigns a random identifier, okay, of the object employee 1. Okay, so here ID of M1, ID of M2 will yield different identifiers representing the unique OID for each instances. Okay, this is a syntax for I mean assigning a different or unique OID for an object in the Python code. Okay, so object identifier is the first approach to use OODB. Okay, a second thing is like encapsulation. So where here will be like encapsulation is like, so we'll be having various approaches which incorporate the encapsulations. So where data and related methods are bundled within the objects. So encapsulation is nothing but where we'll be like having more number of functionalities which has been packaged within a single objects. So here is like for the encapsulation we have an example over here. So when you are just having a bank account, we can do a multiple functions, okay, on the same object. Okay, for example, if I have an integer variable, I can even perform the addition, I can even perform the subtractions. So multiple functions can be packaged for a single variable. The same case when we have a bank account is a single object, and I can do multiple functionalities on that account. I can just deposit the amount, I can withdraw the amount, I can check the balance for the amount, I can transfer the amount to the other persons. So which means that for a single account, within a single account, I can perform multiple functionalities. That is the magic of encapsulations. Okay, so we have a class, okay, which is nothing but we are just declaring an object here, class bank account, and then we have a function here, and with the parameters I'm just having a passing that the function, okay, account number and the balance checking. So here is like I'm just depositing the amount and then I'm just checking the balance of the amount. Okay, so we have two methods here. Okay, so one is deposit, the other is the get balance. Okay, so two method on the same object. So here you can just have the bank account here and then I'm just passing the account number because this is a parameter of this bank account. The self is nothing but it's a bank account function method. So inside that we are passing account number and we are just passing the balance. Okay, so next is like we are depositing 500 now, it just go here and deposit the balance 500 here. Okay, so balance is already we have 1000 now, 1000 will be added up with the 500. So my balance get balance method will throw me the output as 1500. So for single object, okay, I am performing multiple functions. So in this example, the balance is encapsulated within the bank account class, only accessible through public method like deposit and get balance. Okay, so this is the single or simple code, okay, for performing the encapsulations. So here we will be like having the other approach, which is nothing but inheritance and polymorphism. So regarding the inheritance and polymorphisms, so which we already discussed in the last video, so where like we have also seen some examples for inheritance. So inheriting the properties, okay, some class can inherit the properties from the base class, the parent class, some behaviors or properties, something like that. Okay, and also polymorphism is nothing but allowing the objects to behave differently based on their class. Okay, so same object will have a multiple behaviors, so based upon the situation. So or we are also like performing we are also incorporating the polymorphism in real time. So as a person we are an object, so we behave differently in different environment. Okay, in the like working environment we'll be like behaving like an employee, and in the family we behave like a mother, we behave like a woman, I mean wife. So we have various functionalities, various behavior also there, that is called polymorphism. Okay, so this is also a important one for OODB for an object is considered. So here like we have an the thing like class animal, which is nothing but a base class. Okay, so base class is like I have a dog, it is an derived class which derives some properties from the base class. Okay, and will be adding up with some personalities or it come under that category. Okay, it is a hierarchical thing. So under animal we have a dog, the dog comes under the animal category, again cat is also coming under the animal category. So dog behaves like we'll be having some speaking method. So we have some different kind of unique speak method, because in the animal we have the speak method has been given here, declared here. This property has been derived by this dog. So and by adding thing along with that we can add the its own characteristics. Okay, so here is the thing like which involved in the inheritance properties. And then here so animals is equal to, we have a list actually, dog and cat. For animals, in animals we will be like having thing like where which we will be like implementing and base class, and where which we are just having a dog and cat and inherited from the animals. Okay, so here this is a concept of inheritance and polymorphism. So same actually animals, but the thing is like they are different, they are behaving in a different way based upon the category. Okay, so next is like complex objects and composition. So here is like for creating a complex objects is like when we have an to be like to be made up of other object, when we have a like object inside the object, in that case we'll be like working with complex objects. So here like we'll be having an address actually. So actually like each person they have an address. So here which means that I will be having a composition and relationship. Okay, so where which will be like composite, which means each person they have an address. So address will be within a person, it's a general thing actually. So we'll be having an address and we will be having an two different object actually. Address is an one object and the person is another object, but address comes within the other object. Okay, so that will be having on person and object. So here the person has an address object showing how composition allows the complex object relationship. Okay, Next is persistence. So persistence is like allows the object to be stored and it can be retrieved later without losing their state. Okay, so persisting, like when we are working with an updations, okay, read, write, transactions, all these things. So that persistence concurrency, like when we are doing concurrent transactions, in that case persistency will be an added advantage and added credit for that. Okay, so this is very important regarding the transactions, all these things to maintain persistence. So here in Python for OODB we use such as ZODB, which is nothing but ZOP object database. We can persist object directly. So by importing this library, so we can just perform the transactions also. Okay, which means that when you are doing a multiple transaction at the same time, that time your thing will get persist. Okay, the state of the object will get persist. Okay, so so here is like a customer. So we have an object declaration here, and then now we are setting up the ZOP database storage. So where which we are opening the connections, all these things, and now we are adding the customer with that, and now we are doing a transaction here. Okay, and then we are committing transaction. Committing is nothing but saving the transactions. Once the transaction is saved, okay, the last transaction will be replaced by the new transactions. Okay, so here to retrieve data I can just get the root. Okay, so where which will be like getting from the list. Okay, from the based upon the customer we can retrieve that in the database from the Zoop database. So transactions will be like maintained and persisted when you are performing a simultaneous transactions. That is called persistence. The last approach is like OQL. OQL is nothing but object query language. So in relational database management system we use SQL. Okay, standard query language, structured query language. Okay, so here we will be using OQL. So here like this is a query, how to write a query for OQL. Now you have to use so suppose we have an employee, okay, object in a OODB. So employee is an object here. Okay, so in OODBMS we used to mention that it is an table, right? So but here it is an object, and for that you have to create an object alias. Okay, so here we use E. Okay, so where which E represents the complete object employee. So and then when we are just giving E dot name, which means that E belongs to this employee. So E dot name is nothing but one employee names. Okay, you can just have multiple objects like E1, E2, E3, something like that. Okay, so E1 represents the first employee name, E2 represents the second employee name, something like that. So here E dot department. So again like this employee's department I'm going to get it, and then so this is how you have to write a query for OQL. Okay, so select E dot name from the employee where E dot department is equal to sales and salary greater than 50,000. Okay, so we have these are the attributes for that particular object. Okay, so the complete query is to retrieve the employee name. Okay, who belongs to the department sales and who are getting a salary greater than 50,000. Okay, so this would return the names of the employees in the sales department with a salary over 50,000. So this is a query OQL. Okay, to write to return based upon your requirements. Okay, so where which you have to mention the object and we will be having an attributes like name, salary, sales, all these things. So this is the syntax for writing OQL. And then last one is like versioning and concurrency control. So when you are just different versions of objects can be maintained. Okay, so when you are working with multi-user environments, this concurrency control and like a persistence. Okay, the same like a persistence here. So in the system where object represent documents, versioning could allow tracking changes over time. So we already know what is versions, right? So when you are just having an original document, when you are updating thing, we always have the version 1, version 2 like that, so that the original document will get persist. Okay, will just load for some other time, some threshold time. Okay, later on it can be removed. When you are just not frequently using now, then you can remove that and you can just have only the recent updated documents. So that is called a versioning. So instead of removing the original document, we just keep that, and for tracking the change, how many changes we have been made for that document, to track that changes over the time. Okay, we use the versioning concept. And concurrency control is nothing but when you are performing multiple changes, we have to be ensured that it is not affecting the original document. Okay, we always give a save as. Save as is nothing but we won't have that, whatever change we do, that will not affect the original document. Okay, that is a concurrency control. So that editing and the changes, frequent changes, needs this kind of features. Okay, versioning and concurrency control. These are the other approach which is very important for maintaining an advanced data, working in an advanced database. So using these approaches, OODB systems are well suited for applications like CAT, okay, geographic information system, and multimedia applications. Okay, so fine. So we have discussed the various approaches. First one is object identifier, encapsulation, and then inheritance and polymorphism, okay, persistence, and OQL, and versioning and concurrency control. Thank you. Happy learning.